Hello everybody, I want to welcome you to the Commodore 64 C64 Brain channel. This is Steve. I'm coming back with this video. It's going to be for Project 17 sound effects. I know it's been long overdue, but here it is. So what we're going to be doing is exploring how to create various sound effects for the parkour game demo that I've been working on since 2017. You know, having the right type of sound in your game adds a variety and it keeps the user engaged. Whether you're shooting at aliens or moving up in the scrolling background in space, you know, barreling deep in tunnels, fighting enemies, having sound is essential to add much more kick and replay value for your game. So in this session, I will be demonstrating some sound effects that will be implemented into the parkour game demo I've been working on for Project 17 sound effects. Some specific examples are the jumping sound, the walking sound, the raging river, punching sounds, combating enemies that come into range. And I've actually been working on a 12 for this too, so I'll be able to, show you that as well. So what I'm going to do here, some of the examples I'm going to have here, I'm just going to kind of first, for those who are kind of new to Commodore 64 or just coming to this channel, show you where like all the original Commodore 64 sound effects come from, which obviously is a lot of their games out there. There's games out there like Ghosts and Goblins, Shinobi, Montezuma's Revenge. These are just some of the examples I'd like to show you. So I have here a screenshot for the Ghosts and Goblins game, and it has its own weird sound effects and stuff like that. So a lot of the games out there have music in them and no sound really, so I wanted to make sure I had something that had sound even if they have music in it as well. The Shinobi, obviously I do believe that one has the music as well, but it has the sound effects as well as you can hear in the actual game. I think maybe even at combat if I remember in that one. Another one here is Montezuma's Revenge. So Montezuma's Revenge, it has some, I think when he climbs up and down the ladder, and I'm just trying to recall this, but there's various sound effects you'll hear in this game as well, and also may still have the background music, but that's for another session. Okay, some of the other things we're going to be discussing here is the SID register. For those who don't know, in the Commodore 64, there's actually a chip that's dedicated to the sound, which is known as the sound interface device, and it allows you to take advantage of like using waveforms, random sounds, and create some very interesting musical notes. And you can emulate all types of instruments such as the piano, guitar, keyboard, and so on. So to kind of get into this as a deep dive, I want to also look at what's called the Map in the Commodore 64 book. And I, of course, as always, I don't think I have my own. Apparently I do. So the Map in the Commodore 64 book, this one's actually for the 64C as well. So for that, we can actually dig more into the sounds and kind of look at them. Now, I know a lot of people are probably going to be like, sounds, they're kind of complicated and hard to understand, and may require some kind of music theory. So I'm hoping that this video is going to move away from that, because I do have a program that I created in BASIC on the Commodore 64 that I'm going to show you later that will actually, it's actually called Sound Switch, and it will actually kind of emulate some of the sounds and allow you to control them with the joystick and stuff like that. So hopefully we can move away from that. Those people who feel like, it's impossible to create the exact sounds you want on the Commodore 64, because I felt that way too until I created this program, and I'm like, wow, I can start really do some pretty cool stuff with it now. So to get back into that, there in the memory locations, this is from hex D400 through D41C, for those who need to know decimal, 54272 to 54300. There's 3 voice ranges that manage frequencies. Frequency, which is our voice one, it covers 8 octaves, which allows varying pitch from 0 up to about 4,000 hertz. And according to the book, as I showed you here, the equation matching this formula looks like this, and I'll just kind of read it out here just in case I don't put the screenshot up. It's frequency equals, and then quotes, register value times the clock divided by 16777,216 hertz. And this register at D404, 54276, this is the one that controls your waveforms, and you can choose between, essentially I think it's 4 independent waveforms I was mentioning here. And there's anything from a 12-bit pulse, which determines the proportion of time that the rectangular wave remains at the high part of the cycle. And there's other octaves and stuff you could do, that control it as well if you set filters and stuff like that in it, and also resonance with it. So it can get really complicated. So I'm going to throw some screenshots here to kind of go into all this. But essentially, the pulse waveform is going to allow you to hear sounds like the ocean, a shooting gun. You're going to hear tones and stuff like that. So the main three that you're looking at is the triangle waveform, and then we have the next is the Sawtooth waveform, and I'm trying to do them in order here as I remember the pulse waveform, and then finally we have the I always pick this one, the noise waveform, and then we have the randomness too. You can also add where you can control the random sounds and stuff like that. These are just by setting different bits here. As you look here, I'm showing you 54276 here, where you can see the voice 1 control register. This is just for voice 1. Remember, there's 3 voices there. So in here, you can control those various sounds in just that one range of octaves with those bits. So I did slightly mention the next one here, which is the envelope control. This register allows you to reach a volume peak, and then you can level off to intermediate value, and then it kind of fades away. And this is the part of the sound that rises in intensity at the peak that's called the attack phase. And after it begins the downward spiral to the immediate level, this is known as the decay. So I always think like a hill, if I'm not mistaken, like you're going up a hill and you're going down a hill. The kind of basically the sound is rising and then it can kind of fall. But there's also a period in between there, which is also known as a sustain. So now if we added the sustain, you're rising and you're sustaining, so you're on that horizontal platform until you start falling again. And that basically cuts out the sound, and it basically what's known as the fading out of the sound. So, and also the release cycle, so sustained release. I called it fading out, but there's actually, they call it, the technical term, sustained release. So, to be clear on that. So, the voice 1 attack decay register, it has these specific bits from 0 to 3 that sets the duration cycle. And then you have, of course, the attack cycle, which rises from 0 up to the maximum amplitude, containing bits 4 to 7 as well. And again, you can find this all in that book. Basically, I'm just reading from the book here. Okay, everybody, what we're going to now do is we're going to explore the Commodore 64 basic sound switch program. You see I have up here on my screen. And what I actually have going on is I have my diamond capture plugged directly into my monitor. So it captures video directly from my Commodore 64, which you can't see, but it's right here in front of me. So what I'm going to do is kind of demonstrate how this program works. You can kind of see it's broken down into VC1 waveform. That's waveform 1. I'm sorry, so for voice 1 it's waveform, and it's currently set to, well, it's Sawtooth right there, but this starts on triangle right there on 17. And then here underneath that we have voice 1. This is the low bits for the frequencies, which is currently set at 59, and you can control that by moving it with a joystick. And then underneath that we had the high bits for that, which is currently set to 36. And underneath that you can see there's a decay range. Remember that decay and that rising and that falling. Attack decay. I should probably call it attack decay. But down below there you can see, which I'll go into, the actual code that's going to be output to create that sound. And then below that we have the sustained range, the sustained release right there, and it's set to 12. So I can control those actually with my F1 keys in general. So F1 and F3 here will change and rotate those. If I press them right now, you'll see that they actually change. See how it changed to 7, and then now it's at to 12. And if I wanted to change the other, I just can control it right there, like that. So we'll kind of go through some of the sounds here. So I kind of push this back all the way to 0, for example. You can hear it's just like a regular sound there. And then we kind of move it up a little bit. You hear how it's changed a little bit. Now we're into a different tone. We'll change it again. And you hear how the tones keep changing once I hit those right pitches on it. Because there's very specific ones you have to use on the Commodore 64 to get it to work right. So you can kind of hear it's kind of changing. And I hope you can hear this. I have basically the only way I was able to get this to work is I had to sit next to my monitor and actually have my audio plug directly into the monitor and plugged in my diamond capture. So you can hear the output from my actual monitor because I could not get it to work through the game capture without doing, it was just doing some horrible sounds. So it sounds so much better this way. It's just loud here on the outside. But anyways, so we can control that and change those weird sounds. Now I'm going to press the space bar, and I didn't put that on the screen here, but the space bar will switch the waveform. So now we're into the Sawtooth waveform, and you saw how it changed, and you heard how it changed, right? Now if I press it here, there's basically no sound coming from that one. Now you hear how it changed again? Now watch. So see, with this kind of program, which I'll put up either on my website or I'll put it somewhere on GitHub where you can see it, you can actually control and create your own sounds just with this. Because what I did is I listed the code below so you can see exactly what's going to be happening in your Commodore 64. And I had to refresh the screen because the numbers don't always add up correctly. So I'll press the space bar again and we'll move into just the 3 I have set up, which is the noise waveform. So if I move this all the way back to 10 or even 5, for example, and you see how the numbers are messing up there, you hear how it changes. Watch. I'll take it all the way back. Actually, we need to change this one too. I forgot. Oops. There we go. Now you hear how it changes. It almost sounds like a shotgun or something. See, it's lower because we're in the lower range now. We're running in those lower bits. So as you change it more, you'll see it eventually, as you play with them, it'll change the sounds more and more. And I could have these preset to values, but I just wanted to show you how it actually works when you play with it this way. And again, we could still control those attack decays. You'll see those change too. Now this one kind of slows it down because remember, what we're now doing is we're releasing really fast, right? As soon as we're decaying, we're going to the sustain and we're cutting off that sustain almost immediately. That's why you hear nothing. Even if I go to a different voice, here, it's like a dink. It's just really quickly, just throws it out. But if you go back and you change it, you're going to get the longer range. Now it's kind of, you know, drowning it out more. You can hear it flowing. And that's a higher pitch, of course. I'll drop it down some more so I don't break any windows here. And there's a lower sound. But that's essentially one of the sound programs I want to show you. So next I'll show you some of the basic program examples that are out there for some of the simple sounds. But this one is actually a really good way to work with your own sounds. Okay, now, so what I'm going to do is I'm going to show you some Commodore 64 programs I have. I do have one here currently that is going to create like an alien sound. This is the listing for it. Listen to this. Okay, and then what I'm going to do is go through a few other sounds here. I have one here called Weird Sounds. You can see the listing again. And here we go. And then there's a rising sound. And there's a listing for that one. Trans sound. I just named it the wrong one. Okay. Kind of does this to go out. Okay. Next one here is a twang sound. Listing for that one. Bounce sound. And this one's kind of interesting. And the listing for that one. Alarm sound. And you kind of skip ahead here because there's like whole slew of sounds I could really go through. Fireworks. This one was kind of interesting when I came up with this one. Shooting range. That was also my own creation. So the general idea here is you can see, based on what I've been showing you, that with the Commodore 64 waveforms, you can create all kinds of interesting sounds. All you're really doing is you're playing with those high and those low pitches, which you see in the lines here, and you're also playing with your attack and decay, depending on how long you want it to go. You can see here, just looking at this program, for example, in line 50, we have S+5, that's our attack. Decay set to 12, and then our sustained release is set to 12 here, so they're basically in equal pitch to each other to kind of give you that longer, sounding sound. And of course, this line is the volume, and this is the one that actually creates your voices. So we have a voice here, a low of 55, and low here of 23, and a high here of 55, to read those backwards. And of course, the waveform here, which is set for a variable of 129, is our noise waveform. And then what we're essentially doing here is we're just tracking it down, so we're setting it to a higher and then dropping it down. And as you drop it down, that's how you hear that. So if I reversed it though, it would sound like the opposite. Let me actually just show you that here. That's all I have to do is say 50 to 100. See how I changed the sound? It sounded like that time it was like kind of going out instead of coming in, So kind of interesting stuff you can kind of do. And also for this one, I do have a random value down here going as well. I think I have something going on with this one. Let me see here. I may have been doing something else with this, but I didn't actually use the random value. Oh, actually I did here. So I set it to a certain delay to randomize up to a specific period of time. Basically in increments of 50 up to 190. It's just doing a random increment there. So that kind of stuff you can kind of play with. Just to kind of let you know, those are the sounds I've been working on. Of course, this is the one I wanted to add. I wanted to add this one directly into the actual assembly language program because we already have jumping in the actual game project. I don't know if you can hear that. That one almost sounds like a basketball when I hear it. It's like kind of weird. It's like a doing. But yeah, those are the kind of things you can do in all the step ones too as well. So you can kind of see it. And you see what this one's kind of doing is it's kind of playing with the low value here, and it's doing some subtractions based off of a lower pitch of 15 and dividing it by increments of saying how many times is it going to be indivisible by this number of incrementing of I here. Outside of that here, to kind of switch the display and transition over here a little bit, the next segment here, or segue into this, is just to kind of show you here a SID control chart before we actually get into the code and stuff like that. And if you want to take a look at that, it has all the values and everything that we've been going over, from the low frequencies to the high frequencies, sustained, release, and all that. And you can see all the different voices in here. And it's got the pot registers and stuff like that. In this example, I'll kind of shrink it down here to show you. So this is just directly from my script here. So this is the SID control chart. And I found this in a book here. Actually, it's in a Commodore 64 music book. And this is what I was talking about. You can actually see the low frequencies, the higher frequencies here. We've been playing with those sounds even in Sound Switch when I was getting those higher and those lower into those higher pitches. And of course you got, your waveform here at 54-276. This is the one where you can see and play with the triangle, the Sawtooth, the noise waveform, the pulse width, and those kind of sounds you can make. And attack decay, we've already talked about the rising, falling, and holding of the note and dropping. That's our sustained release. And of course here you repeat for the next voice. So you have voice 1, voice 2, and voice 3. And they're kind of broken down here. Voice 1, voice 2, voice 3. And then these are the filters. I haven't really gone into them, but the filters are really interesting once you do play with them, because you can come up with some unique sounds and kind of muffle your sounds. And sometimes you can kind of grind out some pretty interesting sound, and even with the oscillators and stuff like that, really make some interesting things. And of course, we got the filters and the resonance and stuff like that. So, and envelopes, don't only forget the envelopes too. So there's a lot of different things you can do with the sounds once you really start getting more advanced and stuff like that. Okay, so the next thing I wanted to kind of show you here, and then maybe just a little bit away with the cover of the screen there is these are basically the sound register values. And here you can actually see you can create different kinds of instruments from, you know, piano, flute, harpsichord, xylophone, accordion, trumpet, and noise, as I mentioned earlier. So these are the kind of things you can do if you play with your sound as you get better and better with your Commodore 64. And these are the actual values that are being set here individually for each of these based on the registers and stuff like that. So I had a better example to show you somewhere else here, or maybe I'll put that up on the screen here later to show you that actually where this is all broken down. I believe this was in the Commodore 64 system guide. I know I found this somewhere. But yeah, these are kind of some of the things you can do with sounds, and just kind of things you can kind of play with them and stuff like that. And then, of course, you got the pulse width and stuff like that to be able to control those different frequencies too as well. So as you saw in my program, you got the joystick. You can kind of emulate sounds like that. And of course, when you use a keyboard, you can use it to kind of control sounds. I have many other sound projects I'd like to show you. There's a lot of assembly examples I've made. I just don't want to make this video so long, but I come up with quite a few different trials and errors before I finally, came up with the sound switch that I ended up with. Okay, everybody, I am back here, and this time you're finally going to be reviewing the game code so you can see the sounds that I actually implemented, and I'll go over them one by one here. First, I'd like to show you the different sounds we have. So the first one you see here is actually the jump sound. So whenever the player jumps, he's going to create a sound. Let's go down here. The next one is going to be a falling sound. So whenever the player falls off a ladder or anything, it's going to make a sound that he falls. The next one here is going to be a raging river. I should have probably renamed this because it's actually a swimming sound. So when he's swimming in the river, left or right, it's going to make a sound. And finally, for now, the last sound we have here is the enemy shooting sound. So whenever the enemy has the player in range and starts shooting, you'll hear a shooting sound. Now, I still need a little bit of work on this because it basically only does one shot at a time, and it stops after he keeps shooting. So we'll work on that later, but I just wanted to get a video out to show you. So now to explain it all, right? So the falling sound here, if you recall from the very previous sessions we went over, we have the volume control. That's pretty obvious. And then we have the different waveforms. You'll see this one, 129. If you recall, that's the noise waveform. Sounds like the ocean shooting gun sound. In this case, I'm implementing it into a falling sound to kind of emulating an effect when he falls. You'll hear it. And then here we have the pulse waveforms. This is basically allowing you to control those tonal frequencies that essentially you'll be able to see exactly how it sounds once you get the right settings, whether it's high or low. Okay, the next thing here, we've talked about this many times, this is attack decay. So basically the rising and falling of those voices, and here we have a longer sound. So when he's falling, it's got like a longer sound to it instead of a cutting off sound. And then down here we have the frequency controls. So we're basically controlling that low byte, and we're doing some information here. We're adding 125 bytes to it here as we're continuing to fall. That's for the low byte. And then the high byte here, we're just transferring in the data into the high byte. So basically it's taking all the values here in the X register from 255 all the way down to 55, and it's adding them into the low and the high bytes. And also on the low byte here, not forget about it, actually, in addition to, it's actually subtracting 55 from the X register, and then we are actually taking that and we are dividing it by, I put 8 here, but this can actually be 2, because as you go each one, it's going to keep dividing it. So we're only using 1 because I was trying to come up with a different sound, so I basically isolated these and down just to 1. And that seems to do the trick for now. I may later do some more stuff with it, but I just wanted to show you how it works. And then finally down here, we also add recurring 4 here and setting this into 54 to 73. which is basically just adding the addition of 4 on top of this. It's basically just another way of creating additional part of the sound. We could, for example, change this to like 10 or something to kind of increase the pitch of the fall instead of one the lower tone. And then down here, the waveform gets shut off. So as he's falling, it emulates the sound of falling. And of course, I mentioned here, this cycles through it 15 times until it's done. Once it's done, it goes, it keeps going through all the way up here, excuse me, to sound results 2 until it's done, and then it just exits. And the Raging River, kind of similar, except for this one, we're using voice 2. So that was voice 1. Now I'm going to use voice 2 because the river can be running while the player could still be jumping or the gun could be firing and, you know, the player's falling. I have a separate voice for that. So kind of similar thing here. This is just saying if this is different here. So it's saying if the attack decay is actually going for voice 2, we want to continue that until the sound has faded all the way to 0. Once it fades to 0, we want to clear that chip. I didn't mention this, but basically this is clearing all the registers from 0 to 24, starting at 54 to 72, all the way up to the very end there. It just takes out all the SID registers and wipes them to 0. What you want to do, you want to clear the SID, otherwise it'll basically interrupts the sound and it leaves stuff hanging, and sometimes it just cuts the sound off. And here we're doing the same thing. We're just establishing the waveform. This is going to be the noise waveform. And then we're setting the pulse width for this one. Actually, I'm sorry, I didn't mention this, but in this one, and just with any voice from voice 1, 2, and 3, you can set a pulse waveform to kind of control the waveform a little bit better. So maybe later I'll play with those, but I just wanted to kind of throw them in there just so you can do those. And I just have P1 and P2 set for those if I decide to use them. And down here we got our frequency controls, our low and our high byte. And now all I'm doing is adding direct values in here into the low and the high bytes here. And I used my sound switch program to come up with these sounds. So that sound switch program is really paying off here. And then we have our attack decays. So basically we're just getting a really fast sound on the river. So every time he moves, you'll hear it just left and right real quickly. So, and then down here, and then it just exits the routine. So the next one we're going to move on to will be the enemy shooting sound. So whenever the enemy has stopped and he's firing at the player, it's going to make a gun sound. And same thing again here, we're checking to see if the attack decay has faded away, so we can clear that sound chip so we don't continue the sound. And down here we have the volume control, and we have the waveform. We are once again using the noise waveform. That's going to emulate the shooting of a gun. And we have the low and the high byte. Again, we're not doing anything special. We're just basically setting lower frequencies on these to get that lower sound of like a shotgun blast going through. And then we have the attack decay, again, kind of cutting them off pretty quick here. So the 12, basically when they're equal like that, that kind of makes a shorter sound. Whereas if you raise the sustained release, it holds it longer and can make it go out further. So. But these are also various bits. I didn't mention you have to set these exact bits. If you don't set the right bits, then it will cut off the sound. So maybe I'll talk about that in another session, but that's kind of what you want to do. And that's the purpose of having that a sound switch program, because it allows me to track those sounds that go through it. Okay, everybody, in this session, what I'm going to do is I'm going to demonstrate some of the sounds here. I'm going to break this up into a couple sessions right now, because it looks like when I turn the enemy on right now, there's some bugs in it, and it basically starts messing up the screen really bad, and eventually I can't even move. So I'm just going to demonstrate a few of the different sounds, and then I'm going to separate that one in for the enemy movement. So right now the enemy's not going to move or anything, and then I'll turn that on and show you that routine later when he shoots the gun at you. So right now, I should be able to move like that. You'll see the enemy remains idle. If I press my button, you see I can, it makes a sound. A jumping sound, and when he falls, it makes a falling sound. I can move up and down here. When I fall off a little bit, I can recover myself. Okay, so what I'll do next here is I'm going to fall off and land in the water down here. And also I can't fall too far or I'll end up dying too. I don't want him to die. He lands in the water, he's not going to die though. Now here's the interesting thing. If you remember when I showed you earlier in that routine, whenever you're moving left and right, it basically checks to see if the attack decay is at 0 before it turns the sound off. And the reason why I did this is this. So when he moves and I let go of the joystick, the water will fade out because of that fading out it's checking. And then again, I'll be able to do it each time over and over again. So when he's moving, it makes the water sound. Only when he's moving though, in the water, that is. If I hold it, you'll see it'll kind of continue in spurts. It's actually holding really well here. If I let go, it fades out again, right? So. Yeah, as long as I move in there, making the sound. Okay, now that I actually have turned on the enemy, I'm going to demonstrate the shooting sound of the enemy. And as I move the joystick here, you see how he's shooting, but it only picks up one sound. So, and once he stops there, then it's supposed to stop the sound, but it's only doing one sound. See, I did one there. Move here, it might shoot him again. There he shoots, but see, I keep shooting and it doesn't keep going, so I'll need to fix that later. I'm just kind of showing you how it works on that part. And that's the shooting sound from the enemy. Okay, everybody, as we wrap up this session on the Commodore 64 video 17 for the sound effects, I just wanted you to know, thank you for joining me, and always please subscribe to the channel. And we went over and we reviewed the SID registers today and, you know, how they work in general. And then I kind of went into some examples showing you the basic programming, and I also showed you the assembly language programming examples, and just kind of broke those down into different examples along the way to kind of show you how sounds work, and just to provide some more information inside the chip itself so you can understand anything from the attack, decay, sustain, release, the pulse, waveform, the frequencies, and how they all fit together. And with the sound switch program, we was able to tie this in together and, you know, create programs for the assembly language program that we have going there. So thank you guys again for joining me. As always, like I said, I appreciate, you know, your subscriptions and your feedback. I look forward to seeing more in the comments. Just tell me what you think of this video, and no pun to the, well, the Apple in the background, but I have a passion for Apple. I actually, just kind of a short story, my first computer was actually the Apple. It's where I discovered computers, so it led to this one. Thanks for watching, guys. Have a great day.